These notes are going to show you how to solve equations when you have variables on both sides of the equal sign. There is a definite order and set of steps that you need to go through to make it easier to solve as well as to get you a correct answer. So the first thing we're going to do before we jump into examples is to list the steps to solve these types of problems. Right, so here are your steps to solve. Right, the first one, because you have variables on both sides of the equal sign, you have to get one of them over to the other side. So the best way to do this to avoid extra negative signs is to move the smaller variable term to the other side of the equal sign by adding or subtracting. Okay. After you've done that, you should have the variable on one side of the equal sign, and it now sets you up for a two-step problem. Right? So instead of specifically listing all the steps, I'm just going to say at this point that you're going to solve the rest of the problem like two-step equations. Every now and then you will get to the point where all you have left is a one-step equation, but it's not as popular, so most of the time you'll end up with the two-step. All right, now the rest of these notes are going to be taught to you and talked you through by examples. That's the best way to teach you and show you exactly how to go through problems that look like this. All right, so we're going to do 5 examples together. And then hopefully that'll get you set up to where you'll be successful for what we do in class, and you'll have some understanding of what's supposed to be happening. All right, so take your notes and watch carefully as to what's happening and make sure that you're understanding the process behind it. We're going to start off with a very basic one that has nothing fancy in it, but it does have variables on both sides. Okay, and this is where I highly encourage you to use the wall. So you can see that there are variables on both sides of the wall. You can't combine them together because they are on different sides. So somebody has to move over the wall, and that's where the adding and subtracting comes in. Your two variable terms are 3x on the left side and 8x on the right side. So if you're looking at 3 and 8, if you're going for the smaller one, 3x is the smaller one. To move 3x over, it's already positive, so we want to subtract 3x to both sides. And once we do that, that makes the 3x go away because that side has 0 on it. So now we have negative 7 equals 8x minus 3x is 5x plus 23. And here we are right back to those two-step equations that we talked about last class. All right, so we have to move the plus 23 first by subtracting 23. Again, what you do on one side, you have to do on the other. All right, and then the 23 is gone. So negative 7 minus 23 is negative 30 equals 5x. And to split the 5 and the x apart, we have to divide them. Divide by 5. So that 5 cancels off. And negative 30 divided by 5 is negative 6 equals x. All right, so there's your final answer. But the whole trick to this is moving one variable to the other side of the equation so that you can solve these normal two-step problems. All right, let's take a look at a second one. Okay, if I have 5k equals 8k plus 21. Okay, here's the wall. You can see there's k's on both sides, right? And you can see that 5 is smaller than 8, so the 5 is the one we're going to move. But watch carefully what happens when I move the 5 over. It's a positive 5k, so I want to subtract 5k to the other side. Well, once I do that, there's no more 5k's on the left, but you can't leave air there. You have to have a number until something comes back over. So 5k minus 5k leaves you with 0. That 0 is your placeholder until you get some more on that side. 8k minus 5k is 3k plus 21. And now we're at the two-step part where we can subtract the 21 from both sides. 0 minus 21 is negative 21 equals 3k. We want to split the 3 and the k apart, so we divide by 3. And then negative 7 equals k. Okay, so if something goes away completely, okay, and there's nothing left on that side, you have to put a 0 in place of it to hold its spot until something comes back over. All right, next one. If I have 7g minus 12 equals 3 plus 2g. All right, here's my wall, and if I'm looking at the variables. I've got 7g and positive 2g. Well, positive 2 is smaller than 7, so that's the one I want to move. It is a positive 2g, so in order to move it, I need to subtract 2g to the other side. Okay, and that cancels it off. So now 7g minus 2g is 5g. Bring down minus 12 equals 3. Okay, I want to get rid of minus 12 next, so I'm going to add 12 to the other side. So I've got 5g equals 15. I want to split up the 5 and the g, so I'm going to divide by 5. And I'm going to come out with g equals 3. You'll notice that it's repetitive once you get past that first step, because it always goes back to that two-step problem. Right? And that's what's nice about these. If yours isn't doing that, then you know something's not quite going the way you want it to. All right, for number 4, we have 1 minus 3c equals 9c plus 7. Here's the wall. Okay, now if you look at your variable terms, you have negative 3c and positive 9c. Well, any negative number is smaller than a positive number any day of the week. So the negative 3c is the one I want to move over. Because it's minus 3c, I'm going to add 3c so that it cancels off. Okay, once I do that, 3c is gone. So now I've got 1 equals 9 plus 3 is 12c. Bring down plus 7. All right, my next move is to get rid of the plus 7. So I'm going to subtract 7 from both sides. 1 minus 7 is negative 6 equals 12c. I want to split the 12 and the c apart, so I want to divide by 12. And here's where you've got to be careful. When you type in the calculator, negative 6 divided by 12, it doesn't give you a whole number. Right? It gives you a decimal. Anytime you end up with a decimal and there's no decimal in the original problem, your answer has to be written as a fraction. Right? So right now we've got c equals negative 6 over 12. Well, that fraction can be reduced. If I divide by 6, I'm going to end up with c equals negative 1/2. Or if you already know that 0.5 is 1/2, then you can go ahead and do that part from your calculator. But I should not be seeing decimal answers for problems that don't have decimals in their original equation. Only the ones that start with decimals can stay decimals at the end. Okay, so be very careful as to how you do your problems and how you write them. Okay, so that's something we're going to work on in here because I know that's going to be an issue for some of us. Okay, and then if we take on the last one, we're going to do one with decimals to show you what I'm talking about. Make sure you copy it correctly because with decimals, it's very easy to miss something along the way. All right, so here's our equation. Here's the wall to show you left side and right side. If you find the value or the variable with p, you have 8.1 and 5.1, so the smaller one is 5.1. It's a positive 5.1, so I need to subtract 5.1p to the other side. And now that part's gone. 8.1 minus 5.1 is 3p. The decimal part goes away. Plus 2.3 equals negative 3.1. Make sure you get that negative sign that's attached to that 3.1. Okay, now I need to get rid of plus 2.3, so I'm going to subtract 2.3 to the other side. And I've got 3p equals negative 5.4. Okay, and then I need to divide by 3 on both sides. You can't leave a decimal in a fraction, so you have to physically divide this problem. Negative 5.4 divided by 3 leaves you with p equals negative 1.8. You are allowed to have negative 1.8 because your original problem had decimals in it. So this is an example of when you're allowed to have that decimal, and number 4 is an example of when you aren't. Right? So let's make sure that we're learning those tricks along the way, right? And that way you're going to be successful at these.